Okay, so something's gone very wrong, and I think it's where the smoke's coming out at, right there. Well, that's all, folks. Stay tuned for next week's episode where we use a proper motor controller.
Hello again, it's me, T. Rowan, and it's been a while. I hope you're all doing well and staying out of trouble, you crazy kids. I came to the conclusion that I needed to start making YouTube videos again, and that means building something fast and dangerous. In this case, we're gonna breathe new life into this Jazzy Select 6 mobility chair that was kindly gifted to me by a friend. It'll be more like the Spazzy Select 6 when I'm done with it. Why am I doing this? Why am I using my skills to potentially jeopardize my safety? Because that's what gets views, right? Right? Is that what gets views? I'm not really talking to anyone. I don't have an assistant or anything. To be honest, this project concept is more for me. I usually need some kind of edginess to get motivated to work on a project, but there are many practical takeaways from this project for you guys. I'm essentially creating a blueprint for anyone that wants to take a mobility chair like this, whether it's working or not, and cheaply integrate their own system into it to get it running. So who might this apply to? Well, people that need a mobility chair to get around in everyday life, but may not have the insurance or the money to spend on OEM components to fix it. Students, professionals, or anyone else looking to use a mobility chair as a base for a robot, okay? An autonomous or remote controlled robot. Lots of applications here. Best case scenario with this entire video series, maybe some underground power chair racing league spins out of this. I can only hope. That being said, everything that I do with this project will be open source and available to y'all. So more details on that in the next video. Speaking of next videos, I've broken this project up into a 4-part series. For the second video, we're going to go through the electronics design and control software, and we're gonna have plenty of testing to do. Now, something that's pretty cool is a lot of that testing can be done right here on my desktop with this small scale differential drive robot chassis. All right, so this will represent the power chair. Most of what we come up with can be applied to this without ever sitting in the actual chair. Part 3 will consist of the Spazzy build and assembly, so integrating our entire control system and electronics into the chair. And part 4 will be the ride and test video and possibly my demise. Go ahead and feel free to subscribe to find out if I'm gonna live or not. And last but not least, let's talk briefly about the design overview. The original Jazzy specs list a top speed of a whopping 4 miles per hour and a dual channel 40 amp motor controller and a system voltage of 24 volts. It's tough to find in-depth specs on this motor controller as they're not widely published, and seeing as this motor controller is fried, I don't really have a way to verify the specs. So in that case, we are throwing it straight in the trash.
Throw it all away.
Fine, throw it all away because there's, no matter whether I bought it recently or not, just throw it away. Fine.
All right, so actually, there might be some good components left on this board. It might be worth looking into. Also, how did that get in there? So my original idea for this project was to design and build my own 2-channel brushed motor controller to replace the stock one, of which I started, but I quickly realized that it was more important to just start developing with cheap off-the-shelf Amazon controllers. I mean, worst case, I blow them up and then have to, use my own design to beef up the current capacity, or to use with a higher system voltage, 100 volts or so. So our Amazon motor controller is rated to 60 amps peak and 40 amps continuous, with a system voltage of 10 to 55 volts. So can this motor controller really put out 3.3 kilowatts? We gonna find out, and we got 2 of them. The top speed of the Spazzy, I'm guesstimating to be between 13 and 18 miles per hour, which sounds slow, but remember, this is a differential drive system, so making it turn while at speed is going to be a challenge. Right? So you don't have rack and pinion steering. You don't have a front axle. You have 2 independently controlled wheels. So to make turns, you have to vary the velocity of the wheel. If it turns too slow, you risk missing your turn. And if it turns too fast, you risk capsizing like a boat. For that reason, I'm going to ditch the original joystick module, right? So this is Hall-based. So it only knows if I'm forward, backward, left, right. There's no gradual reading of the position of the joystick. As opposed to a potentiometer like this PlayStation 2 controller joystick, okay? So I'm able to read the entire range of motion of this potentiometer, this joystick, okay? So I know that this is forward a little bit, this is forward more than that, and this is forward all the way, right? Same with left, right, and back. I'm also going to need some sort of orientation sensor or gyro compass combo so that I can detect my heading, right? So that I can feed this and the joystick back into the control loop. That way I know I'm going straight if I'm commanding it to go straight. Or, you know, if I go right, I want 0-point turn donuts. And this thing has plenty of torque, so those donuts are gonna be wild. For the brains of the entire operation, I'm going to use an ESP32 microcontroller, which gives the added benefit of Wi-Fi and Bluetooth capability if I want it. I've used them for other projects, they're great, they're cheap, and we're going to use the Arduino platform for all of our software needs as it's quick and easy. Okay, that's it for our initial design overview. Let's end the video here. Stay tuned for the next video, which will be pretty design and tech heavy, but will hopefully help and inspire many to take on a project of their own. And smash that like button if you like this video series idea, and leave a comment, let's talk. Do you think it's a great idea? Do you hate it? Think it's dumb? Please leave some feedback. And also feel free to subscribe so you don't miss future content. Follow me on Instaham for all the behind the scenes content that you're not gonna get here. I'll see you all soon. And most importantly, be safe out there. No, stop the music. That's not really my style. How about this? Now I just feel like I'm in a truck commercial. Do you get that vibe?
Our trucks are built tough to help you accomplish whatever the hell it is you need to do with a truck. And, you know, you need to stack pallets sky high? We got you. Here we show a stereotypical blue-collar American worker with a truck. Built tough. That's truck tough.